Hello everybody, welcome back to High School Tutoring. I'm your host Manny, and today we're going to be learning about forces. So here's a little introduction to our forces, and this is kind of a topic that kind of just branches out, like how we saw projectiles just branching out of like vectors and stuff. That's kind of what this is kind of like. This is projecting out of vectors, and it's kind of, this is going to be the reason why that all this stuff, that all with like projectiles and stuff was actually able to happen. So, we can define a force as an influence that is capable of changing an object's state of motion. So it's kind of like, let's say this guy is pushing like 100-pound like brick wall and is trying to knock it over, and he's pushing with a specific force. He's going on it, and he's going to be moving that wall. So whatever this is the reason that this wall is moving. The guy pushing it is the reason the wall is moving, which is kind of like this. So a force is whatever this guy does to change this wall. So that's kind of what it is. You can have a pull, you can have a push, same thing. And we haven't measured in newtons, so he's pushing at 100 newtons. This wall is going to be moving at 100 newtons to the right. And so since this produces an acceleration, so if this is at 0, this isn't moving at all. This wall was never moving, and this guy just started pushing it. He's technically accelerating it because he's giving it some speed. So that makes it a vector quantity. So we got to make sure that we have a direction and our velocity, obviously. And the net force is a term that we're going to use for this, and it's going to be quite useful. It's the vector sum. So it's kind of like all the forces put together. So if this guy was pulling at 100, this guy was pushing at 100, that's 200 newtons to the right, putting them all together, and that's how we'd solve. And so now on the topic of net force, let's take a look at balanced versus unbalanced. So balanced forces are forces that are canceled out by each other. So if there's two forces, you can see here with the box example, this one guy on the left is pushing the box at somewhat amount of forces of newtons to the right, and this other guy is pushing at the same force to the left. That means that they have a balanced force. So obviously our net force is going to be 0 because F2 minus F1. So F2 is here, let's say it's like 5, F1 is also 5, that would make it 0. That makes a lot, hopefully that makes sense. So that means that there's no acceleration in the actual movement. Since the forces are balanced, there's no change in the box's movement. So if this box was rolling, if it was like rolling across here, that would be a constant motion, and if it's just staying still, it's in no motion. So now if we look at unbalanced forces, it's now, our net force is now not 0. So basically, see this example here, this team of 3 is pulling at 300 newtons to the left, and this team is doing the same to the right. They have a balanced force and they're not moving. But this team is now pulling 400 to the left, and this one's still pulling 300 to the right. That means that this one will have a net force of 100 newtons to the left. So if we can see here, quickly just steal a marker, quickly just grab a marker, and there we go. All we have to do is look through here. You can see 400 minus 1 or minus 300, that's equal to 100 newtons. And since we see the direction of the left one being bigger, that means it would be going to the left or west, and etc. Something like that. So let's take a look now at our examples. So we have a couple examples. All of them are going to be unbalanced forces, and we just have to find the net force. So here it is. What is the net force of each scenario? We have 1, 2, and 3. So I'm going to give you guys a moment to just pause the video and do this yourself, and then I am going to come back and show the solution. Okay, I hope you guys took a little bit of time by pausing the video to try and solve it, but now I'm going to show the solution. So we have two forces moving to or pushing to the right of whatever this shape should be, maybe a cube, and we have 40 newtons from this top guy and 30 newtons from the bottom guy. Since they're moving in the same direction, we have to add these together. So if we do a little bit of this, we'll do 40 plus 30, that's equal to 70 newtons to the right because of the arrow direction. So the box would be pushing to the right at an accelerating velocity. And there we go. That's our first example done. So now let's do the second one. So now we have the same guy here moving 40, but this time the other guy is moving against him at 30. So that would be 40 minus 30 and that's equal to 10 newtons to the right. So since this guy is still pushing at a higher force than this guy is going to be moving this box to the right more by 10 newtons than this guy trying to oppose him to the left. And this scenario is one that we haven't really seen too much of, or we haven't even talked about this. We haven't even seen this example. So if you guys want to guess on what to do with this, then yeah, I'll give you a moment again to just try to solve it yourself and see what you can do. Okay, and I hope you guys paused the video a little bit. So we now have a guy moving to the right at 40 newtons, and we have a guy pushing up at 30 newtons. So if we think about this as just a triangle, so we have this guy at 40, and then not drawn to scale, this guy 30, and we want to find our resultant, because remember, a force, the net force is either the resultant, the vector sum, or all the forces. So we know that since it's supposed to be the resultant, we just got to find the hypotenuse. So we do 30 squared plus 40 squared in a square root. And if you want, grab a calculator. I'm going to grab mine right now. And just a moment. Okay. And let's see here. So we have to do 30 squared. So here we go. 30. Okay, so 30 to the power of 2 plus 40 to the power of 2. And all that will go into a square root. And we're going to get 50. So 30 squared plus 40 squared, like rooted, is 50. So that'd be 50 newtons, and that would be facing northeast. You can see here, because in this scenario we moved right and up, and then this would be our theta. And we should find our theta value, or our angle, but in this example it's not needed. We're just trying to find the net force. So yeah, that's really it for this portion. There's going to be another video posted on the same day about the same time, but we're going to get into a little bit more advanced stuff. We're going to get into equivalence and stuff like that. And yeah, this is just a little introduction to balanced versus unbalanced, and a little bit of terminology with forces and things like that. So I hope you guys learned a little bit, maybe enjoyed it at the same time, and I will see you guys in the next video. Goodbye.